This is the second of 4 different videos on solving word problems with algebra. In this short video, I will concentrate on solving problems having to do with geometry. Just like solving numbers and logic problems, I think it is important to have a labeling part at the beginning. But because these are geometry problems as well, it certainly helps to also draw a picture, and that is something that I certainly recommend for you to do. Here is an example of a geometry problem that you might see. The length of a rectangle is 2 meters more than 3 times the width. The perimeter is 28 meters. Find the dimensions. As I said, when doing geometry problems, I always draw a picture and label what I know. So it says in this particular problem that the length of the rectangle is 2 meters more than 3 times the width. Because of that, I would probably let the width equal x, and you can see that I have done that in the drawing. It does say that the length of the rectangle is 2 meters more than 3 times the width. So if that's the case, here's the labeling part for my length. The length is 3x plus 2. And then I need to go through and figure out my equation. In order to find the perimeter around a rectangle, I need to add together all 4 sides. And I do have 2 x's. So I would multiply 2 times x to get the length of those 2 sides added together. And I would multiply the 3x plus 2 also times 2 to get the length of those 2 sides added together. Adding everything together, I know that the perimeter is equal to 28. And you can see then I went through and did the math algebra in order to figure out that answer, and you can see that I have x is equal to 3. That means that the width must be equal to 3. If the width is equal to 3, then the length must be 11. And I know that by coming back to my labeling part, or I can come back to the picture part of it, and I can multiply 3 times 3 to get 9, plus 2 gives me 11. So if the width is 3 and the length is 11, halfway around that rectangle, 3 plus the 11 would give me 14, and then I could go the other half the way around for the other 14, and 14 plus 14 is 28. I do want to mention here that even though I solved the problem by having this particular equation, there are certainly other equations that you could have. Some people would say that because I know that this particular side is equal to x, and this particular side is equal to 3x plus 2, halfway around the entire rectangle would have to be 14, because the perimeter is equal to 28. So some people might set up the equation and say x plus 3x plus 2 is equal to 14. And certainly if you went through and solved that, you would also get x is equal to 3. There are certainly more than one way to solve almost all of these problems that I am presenting to you. Here's another example of a geometry problem. Once again, after reading the problem, I'd like you to pause the video, work the problem yourself, and then start up the video to see how I solved it. In order to solve this problem, use the fact that the sum of the angles in any triangle is always 180 degrees. So here's the problem. The second angle in a triangle is 12 degrees less than the first angle. The third angle is 4 times the second angle. Find the measure of each angle. So please pause the video, work the problem, and then start the video back up again. As I said before, when you are doing these types of problems, it doesn't really matter what you let x equal to in the problem, and you can certainly let x equal different things. So I am going to do this problem 2 different ways. First of all, it says the second angle in a triangle is 12 degrees less than the first angle. One thing I might do is I might say x is equal to that very first angle. If x is equal to the very first angle, it says that the second angle is 12 degrees less than the first. So that I would have x minus 12 is equal to the second angle. It says also then that the third angle is 4 times the second angle. So I would need to multiply the second angle, x minus 12 times 4, and that would give me the third angle. Doing the problem this particular way, I can certainly go through now and identify which one of the angles I want to be the first, the second, and the third. It doesn't really matter, this is just a representation, but I could set it up this particular way. Doing it this particular way then, I know that the sum of all of these has to equal 180, so my equation, one equation might be x plus x minus 12, I'm going to put that in parentheses just to show that that is the second angle, plus 4 times x minus 12 is equal to 180. However, some people might say when they are doing this problem that they want x to equal the second angle. If they wanted x to equal the second angle, and it says that the second angle is 12 degrees less than the first angle, that would mean that the first angle would have to be x plus 12, because the second angle has to be 12 degrees less. That would mean that the third angle, which it says is 4 times the second angle, would be 4x. So now I have a different equation. Now my equation is x plus, in parentheses, x plus 12 plus 4x is equal to 180. And this time, as far as labeling my figure then, I might have x being the second angle, x plus 12 is now the first angle, and 4x is the third angle. Notice that in both of these cases, I have different equations. And I am going to be getting then different answers. If I go through and solve this algebraically, I'm not going to go through and do the work right now, I am going to get x is equal to 40. If I go through and solve this, I am going to get x is equal to 28. But remember, I am talking about two different things being equal to x. In the second way I did it, x was the second angle. In the first way I did it, x was equal to the first angle. Regardless of which way I do it, I am going to be getting the same answers. I'm going to get one of the answers, one of the angles is 40, the other one is 28, and the other one is 112. And I would find that out by going back into the labeling part of whichever one of the two ways I chose to do it, and using the information for x to find out the other two angles. Altogether, though, all of these would equal 180 degrees. So these are the three different angles that are in that particular triangle. Before viewing the next video, you might want to practice several more of these types of problems, and you can find them in this module. As always, I am available through email or chat if you have questions.